Hi, everyone. I'm happy to be there. My name is Quentin Adam. I have a very fancy, unpronounceable Twitter handle, which is pretty cool because it was available on every social network, except for the guy who stole it from me on Pokemon Go. So if you find him, please ping me. And my day-to-day job is managing a company called Clever Cloud. Clever Cloud is a company making IT automation. So basically, we're keeping your application online. So as a developer, you just write code, push, and we deploy, automatically monitor, backup, security underlying on the OS, auto-scaling, auto-healing of application, auto-managing the stuff. Basically, you're just writing code, and we're managing that it will be online and on good performances. And we're able to do that in our cloud, in European infrastructure or Canadian infrastructure, or in the infrastructure of customers. And what is cool about this company and what we do is we have multiple clients like everywhere. I think there is customers in 2,300 cities in the world, and we have like small shops inside Greece who sell plants, fan website of Harry Potter, and big bank in insurance and French TV networks. Very different kind of companies and size and teams and projects. And running the support for all this company and all this kind of project, we learn a lot about what is a good idea, what is bad idea, good process, bad process. And we try to give back all this information to the community. So that's why we're here. Okay. The beginning. When we create Clever Cloud, we were young, insouciant people, and basically we say, okay, we want to remove all the clusterfucks about servers, and that's it. So the roadmap of the product was pretty much, we want to do that when you click on this button, this will happen. And the other part was, what we built was an ability for people to upload their code and execute it. So basically, it's remote code execution as a service. And in terms of security, it's kind of the worst situation because you can have people using code to attack us, but there is people using their code to attack all those customers inside Clever Cloud, but you can also have people using code to attack other people, but using Clever Cloud infrastructure. So it's kind of nightmare of everything. And the first thing we have to manage is to be able to sandbox every problem and to be able to be sure that every problem will be contained, and quickly managing the Clever Cloud become kind of nightmare in terms of security, and we all become paranoid. And that's why, in many ways, when we talk about security, you can say, this is breakable, this is breaked, and this is a theoretically a really bad idea because, in somehow, it can be breakable. And we decide that every of these aspects, we need to forget to use it. And we try to work on that. So, first thing I have to say is, we're a very happy team. And when I will explain all the problems we have with microservice, what we will keep in mind is we're very happy to use it. We're forced to use microservice because basically what you need to do is control many servers who actually run code for customers. And every server's hardware part will launch several virtual machines for the application of customers. And all of this together making that at the beginning, an essential core of Clever Cloud, we have to be distributed. So when we choose microservice, we win some good stuff. First is a multiple stack. I don't get why today many technology show themselves that, okay, we are a microservice technology, so you will write every of your microservice using our framework or technology at the same version for everyone. One of the key points of getting microservice is the ability to use the technology you want for a precise task, which is awesome. Raise can be awesome, but if you want to do something very specific and connect with a Kerberos old application right in COBOL, you probably have more success using a Java library because there is lots of people using it. And it will be a good idea to use Java library to write this connector and have a microservice structure to manage that. At Clever Cloud, we're using lots of different technology for several stuff. We have more than 400 microservices working together, and there is stuff writing with Java, with Ruby, with Scala, with Rust, with PHP, with Python, with... I'm not sure, but I think there is some .NET somewhere. There is some C. So basically, there is many possibility of using stuff. And the multiple stack is something we really like because it's allow us to use the better of each tools each time. The other part is the scaling. Admitting you have a software inside the Clever Cloud, which is the API, everyone is using it to log in. And there is, in this API, the logs management able to stream logs directly to customers. The API to log in and the API with log streaming have a very different scaling agenda. And in a monolith way, be able to scale all the stuff together is very complicated. What is cool with microservice is you can manage the scaling of a precise part in just one specific task. And the scaling agenda of every component can be a very cool way to determine where are you going. The other part is the evolution. When you have a software which is a monolith, rewriting it integrally is painful, costly, and you can't do it. But when you are using microservice, each software is really small. So when the software becomes something nobody wants to open, and you say, when people have to work on it, they say, oh, fuck, I have to open this project, I don't want to work on this. Okay, it's time to rewrite it integrally. For example, we are rewriting 3 times the management of Git repository in many different ways. But each time it was best, and each time it was more time allowed to rewriting the stuff because it was the best idea to do it that way. And this is really cool because we never need to say, okay, if writing the integral stuff will be a complexity. So for evolution, microservices are something we like. And for the team management, we are really happy because we are a remote distributed team and we don't like meetings. So with microservice way, the loosely coupling of everything allow us to only work using GitLab SU, that's all. And that way, it works very well on the team management because it's allowed to grow more easily with less communication and needs to understand all the history of the big project. When we're thinking Clever Cloud at the beginning, we say, okay, this is architecture at the playground. We don't know what we have to do as a software. So what we do is actually building a playground where all the developer can just go inside, plug a new software, hack something funny, a new feature for developers, for our customers, and that's all. And when we try to build the architecture, it has to be loosely coupled and hackable. And it has to be easy to just add a microservice without running every other microservice and just play to be creative and add some stuff. So it's something I really want to say is an architecture has to be a playground for you have fun inside it. And this is the way we see the microservice architecture. And this is why, at the beginning, the first thing was the communication between microservices. So, first thing first. There is no trusted network. You know, the trusted network in where you are inside the company, you plug in and you have basically access to everything. This is not happening. There is no network you can trust. There will be always someone who have downloaded the funny PPT PowerPoint file and playing it, and there was a Trojan inside it, and your network is exposed. There is absolutely no network you can trust. So everything with no login, no authentication, no certification is a really, really bad idea. For example, microservice using HTTP API internally exposed without authentication, no, please don't do that. If you really want to have the why you don't want to have some trusted network, we've write a blog post about that, and read it, give it to all your coworkers. Never trust any network, okay? When you are making communication from a server to another server, it always has to be authenticated, encrypted, and auditable. When I say auditable, I want to say all communication have to be logged. So when we will be hacked, we will see what the hacker takes. Because I will tell you a story. Years ago, the NPM team have written a blog post saying, okay, we had a problem of security in the NPM database the past month. Basically, the database was exposing in read and write publicly on the internet, and everyone was able to just edit a binary, and there is absolutely no logs of what's happened. So we don't know if it happens or not. But as the Node.js community is so nice and so cool, we are pretty sure nobody has done this. You see what I mean? You will have security problem. Everybody has security problem. But the point is, know what's the security problem you have, where you are infected, what the hackers told. And for this, you have to be auditable in every way. Get it? The other part about communication is the loosely coupling. Let me explain you. Imagine you are in Clever Cloud and you have events, which is a new deployment with occurred. Okay, cool. We deploy a new thing. Who needs this? This stuff we actually launching new virtual machine. This stuff we actually are writing into the Slack of the people we are doing a new deployment, and the stuff who actually changing the configuration of monitoring to be able to monitor the new virtual machine. If I'm using something like HTTP to just ping all the service, I will have a sequentially HTTP call to each service. And now I want to add a very cool feature, which is have a web notification inside your browser where you deploy a new thing. I have to go on the orchestration manager to add a call HTTP. It's not a very good idea, isn't it? It's not loosely coupled. I want to be hackable like a playground. I want someone will be able to listen the event and put it into the browser. And that's why when you're doing that, when you want microservices communicate together, they will be able to listen another microservice without to edit it. And the loosely coupling is quite important for that. The other part is the routing problem. When you're using HTTP for the communication between your microservice, you have to route the whole HTTP from one service to another service. And somehow it becomes very complicated to manage this kind of stuff. So that's why it's kind of problem. What we want is a message box. Like basically, there is this event, I put it in the message box, and we will see if someone wants it. And someone has to be able to go on the message box and see it. And more, what will be awesome will be able to duplicate the message, because we don't know who will be needed the message. Someone is just starting to see the logs. Okay, who needs the message? Security management, analytics management, I don't know who else. So you cannot predict who will need the message. And the ability to duplicate each event is really important. That's why you need to focus on the ability to duplicate and the analytics and audit. Today, what we do when we analyze the usage of an application on a service, on anything, we basically take all the events, put it in a big database, and run software on top of it. So if you don't trust me for the other part, like the business part of every event, on the analytics and events, you will need to duplicate each event, to put it in the database, and duplicate and read the event. And many databases maybe, because maybe you will try some software as a service for the analytics, maybe you will try to have something internally, maybe you will just have a simple software to just record every event to be able to replay it inside the database. So basically you will need to duplicate the event. And that's why HTTP is not the best idea to be able to produce stuff. I prefer the message broker part. Who's know RabbitMQ? Okay, who is using it? Okay, cool. Who's know Kafka? And who is using it? Does the Ruby binding is good? No, okay. So basically, you can use Redis also, and with Sidekick, for example, as a message broker. It's not done for that, but you can use it. Basically, what I want to say is, if you go on a microservice strategy, just please consider using a message broker approach, because a message broker will be able to just plug in. The simplest way to go is RabbitMQ, because it's really easy to use. You can describe topology. It manages a lot of things. Scala is very interesting. Kafka is very interesting and have a lot of power. But really, give a try to RabbitMQ first. Kafka is interesting if you have a lot of messages. If you don't know RabbitMQ and want to learn, I have given talks about RabbitMQ on a regular basis, and it's called RabbitMQ 101, How to Cook the Rabbit, and it's basically a 101. So basically, you didn't get it, just watch the video, and it will be simple. We base the internal infrastructure of Clever Cloud on RabbitMQ exactly for that. It's because it's easy and pluggable. You need to have another software who know all the deployments. Just plug another queue on top of the topics, and you will receive a duplicate of all message, which is really usable. And for the analytics, you can use a Warp 10 time series database, which is really simple to bind to Kafka or RabbitMQ, analyze and get all the data, and you have thousands of functions to analyze all the bunch of data. And it's everything open source, and Warp 10 is scaling very well because it's based on Hadoop and Kafka, so basically it's scaling. So, okay. The other question about microservice is, what the right size? You know, people are going microservice because it's hype, and they're making microservice like they're doing dependency on NPM with, the noisy microservice armies, very tiny microservice who basically cannot do anything by themselves and putting a lot of data in the network and harming and get to have a very noisy microworker army. And I don't want this kind of stuff because if your microservice is too noisy and too small, you will have a problem. Microservices are more a semantic way to get what's happening. It's not using massive RPC. Remote procedure call is what happens when you call a function in another server and get the answer. It's cool, it's really usable stuff, but the thing is, it's way more slow to ask a server on a TCP connection for an answer for something than getting the function in the class just near you in the same executable. So it's magnitude slower. And using that, you will be using the network. And the network has two problems. It's fragile and it's slow. Network is slow. It's way more slow than just taking another binary inside your own executable. And no network breaks. So basically, if you don't need to speak on the network, please don't do it. So that's why it's important to think about that, because microservices are not here to make a workload distribution. If you want to do workload distributions, there is plenty of possibility. There is the ACA project in Scala. There is Project Alien on the .NET stuff. There is Erlang OTP with Elixir, for example. There is Hadoop in the Java world. You can also use Sidekick-ish if you want, but the point is microservices are not the way to distribute the load. Microservice is a semantic, logic way to disperse your application, not a way to disperse the load. Did you get the difference? And that's why one service has actually to provide a service by itself. Do not do microservice which is not usable by itself, because it will cause you a very complicated, noisy on the network, complicated stuff to manage, and at the end, it will be very difficult to debug because of raise exception and because there is no tools to have a clear view of what happened. And maybe the network has a problem. Maybe you have an ordering problem. Maybe you have a random ordering problem. Maybe you have a problem. You don't know. And if you don't need to split the thing, don't do it. I literally prefer that have fat monoliths, which is fat microservice, communicating together. Remember, people who have actually bought microservice to the world are not a small company. They are a big company with big software and the need to split it. Not company with really slow microservice stuff. So it's better to have a fat monolith and then try to split it inside several if you have a problem. One thing you can have to measure if you are too many splitting the microservice, if you're creating a lot of lib and dependencies and link to multiple microservices, the same internal dependencies, it's because you are using the same code in multiple projects. And maybe you are using the same code in multiple projects because it has to be on the same project. I'm not saying it's always that, but it can be. And if, in the Java world, we have these guys who just discovered Maven, and every project have 400 module dependency management, and every time you want to build it, you have a 3 hours long build stuff, and it's complicated. It's exactly that. Don't do the same thing with microservice. Don't split too much. And the other question is, does the two functions have to be on the same service or not? Or maybe they are just unrelated. Then just split the microservice. The question is, does it have common code or not? Common code dependency or not? It can be a very good question to ask, and the ability to split will be on the good stuff. The other stuff is, does these two microservices have the same data store? A database don't like to have too much different application connected to them. If you can restrict a data store to one service, it can be very useful. And making the architecture and the size of your microservice around the ability to use a data store can be a good solution too. And the other question can be, does this feature have the same scaling agenda than the other feature? Because maybe you will need a very little microservice with a really huge ability to scale and performance improvement, and a larger microservice which is less called, and it can be called once at a time, and you don't need to have too much performance improvement inside it. So in this time, you will be able to split it in the different agenda. To give you an example at CleverCloud, at the beginning of the project, we have the main API, which actually know the topology of user, application, and billing. And we have a billing API, which was separated. And the two APIs communicate every time. Every time. And updates one thing on the API, I will actually to update one thing on the second API. And it was, it was the same code, but split on two projects with network. Bad idea. So we decide to just merge the two projects together. To be honest, the developer of one project wants just say, okay, fuck it, and then merge the two projects. Then we starting to have PDF feature for the bidding. Then the PDF feature have gone to be externalized because creating a PDF is rare and imply other technologies that the API using. Then no, we are more and more often externalize part of the API for the bidding because we know which part can go in another microservice. And this whole story of 5 years old, and when I look at this, I say, okay, at the beginning, we split on terms of, I don't know, logical way to think, but it was not a great idea. And good idea becomes in times because we understand our work. And splitting will be more easy that way. So that's why about that. Configuration on multiple spots. Say, yeah. There is a first possibility of configuration. You just put configuration inside your code. And when you go to production, you made a commit for the production bench, and you rebase on the commit every time. And this is a really bad idea. Nobody have to do it, but I see it very often. The other possibility of configuration is not to build it on code, but using the all new fancy stuff, which is Zookeeper, etcd, console, all the service dependency management stuff. I'm not a fan of all this stuff. We build microservice to be resilient to something is done. And the old configuration will be on a Go project which is really recent and not mature, and would be the spoof of single point of failure of the old infrastructure just to giving you the name of the database you want to use. Do you change the name of the database you want to use like every morning? So, I'm not sure have dependencies to this kind of stuff can be a great idea for your application because it's really frightening for me to have this kind of stuff. What I propose to you is a simpler way. You never change the configuration and runtime. applications are really bad design to change the way the configuration is running. Active Record didn't like we switch the connection pool of a database while it's running. It occurs a lot of problem, performances, thread management. It's not mean to that. I don't know if you know the immutable infrastructure way of thinking, but immutable infrastructure say, while you have built an application, you run it, it's running. You want to change the code or the configuration, you start the application in another place, check it works, change the network configuration, and that's it. But you will never edit something it's running. Okay? Well, I give a talk about that, and I'm pretty sure there is an English version somewhere. But what's important is the ability to be immutable as stuff. And for this, I prefer to have no ability to change the configuration while it's running. The agnostic solution is to use environment variable. Everyone who don't know environment variable? Okay, cool. So environment variable don't change if you have launched your process. So every time you're using something, you just have environment variable and all the configuration inside it. If you want, you can get the environment variable from the etcd or console on everything. It's easy to do because you have clients to just pull everything, put it in environment variable. But the way is, it's agnostic. You don't have to add a protocol or libraries to your stuff. It's very easy to use, and it will never change. So you know it will never change, and you have to restart the application to take new configuration, which is something everybody knows, and it's okay. And at Clever Cloud, what we provide to people to do that, it's a very simple way. So every application can be dependent of others' application or database, and everything can be push, new configuration stuff, and each time you leak an application, you receive the environment variable which the application expose. To expose applications, there is an API, and there is a pre-signed URL we put on environment variable each time we start an application. And if we detect an environment variable change, we relaunch dependent application automatically. And it's a very simple way to manage the service discovery part without to have a spoof inside it. So that's why we propose to you, and you can build the same stuff on top of etcd if you want. When you have to write a configuration for your configuration injector inside your application, I'm thinking you are going too far. Because I'm not thinking it's a really usable way to do it. So that's it. The third problem we have with microservice is the authentication. Distribute the authentication is really complicated because basically you need to distribute the authorization, so you are able to do that. You can perform this request. And which is this guy? Because you need to know the users you are. And if you're using microservice, somehow the stuff we have actually done the session is not on the service you are writing. So, how to do? First, you need to know that there is many solutions or not. In many ways, I see that. So, basically, people are writing service, and the session store will be Redis or memcached, and everyone is going on that. This is a really bad idea. This is a really bad idea for many reasons. First, if you want to change the data inside the session, you have to edit in a synchronous way the code of every microservice. Second, it imposes a very complicated connection management to the memcached and the Redis, which is not a good idea. Again, database like stability. That's why we're using proxy for database because you don't want to hurt them. So that's why we're using pooling for database, because creating connection, stopping connection, creating connection, stopping connection is not a good idea for a database. It will lead to a problem somewhere. Sure, the Redis of the memcached will be a spoof, and it's not clean, you know. It's not a clean way to manage stuff. It's kind of have a shared memory somewhere. It's global variable shared memory. It's this way of doing. So people invent a new thing, which is authenticate using a proxy. So you have the user, you made the request, and there you have a reverse proxy who checks the request and say, okay, I will check on the database if the user is authorized or not, and had some business code, and had on the identity some stuff, and pass it to the microservice if it's allowed. It's a very common solution, and you have plenty of very bad ID based on Nginx and Lua to do this kind of stuff. Okay, what's the problem? First problem is it's very complicated to mock it on the developer laptop. So for the developer, it's painful because you have to start the whole microservice, the whole reverse proxy stuff on his laptop to just work on the code. Second, the security vision is really optimistic because in many ways, this request and the authentication, like I'm allowed to do this stuff, is not signing like digitally signing by the reverse proxy. And it leads that if someone is able to enter in your network, it will be able to craft a request saying is allowed to do that. So you have to be very, very, very consistent if you want to do this kind of stuff, because it's optimistic to think I will never fail on that. The user information the proxy adds aren't requested by the service. So basically you don't know which service we need when you add it on the reverse proxy. So you hope it's a good thing. So sure, the proxy is a spoof, and more, it's several missions inside the same thing. You know, the reverse proxying is, the best reverse proxying is a reverse proxying you don't see. It's a load balancer. You don't want it to imply a lot of performances impact on your request. For me, it's more telecommunications than code. And then this stuff is doing load balancing, network communication, and business code, and I don't know what more. It's a lot of mission for a simple part of the code, and I'm not a very big fan of this kind of stuff because it can lead to a problem somewhere. And there is business code here, there is business code here, there is business code everywhere. It's not a good idea, like really. And it will be really bad for performances reason. I'm not buying that. So people are making stuff like a central API call to authenticate requests. It's what we do at Clever Cloud right now for majority of the requests. So the request is launched to a service, and then the service calls the API to know if it's allowed to do that. And when he calls the API, he say, I will need this information about the user. And the API can reply to him. It's easiest to mock on the developer because it can just like use a pre-production API, login API to do that. The authentication is centralized, it's better, and there is security better handled because you cannot have a man in the middle or intrusion or thing like that. It's way better. And the service request additional info is better too. But what I don't like there is the authentication API is a spoof, and more you can have another problem which is performances issue because you make a request to the API. So from what I need, we need more tools. We need more tools to manage that because it seems to be more a crypto problem than what we have before. There is two tools you can use on this kind of stuff. First one is JWT. It's a way to add, it's a format you add where when I get the request of login, I give you a JSON Web Token. And in this JSON Web Token, I have signing with my own key that you are allowed to using the service. Then when you will call another service, the service will just look at the internal signing and say, oh, it has been signed by Quentin, it's okay. And it will not have to talk to me to manage that, which is really good because if I'm sleeping, it will work. The problem with JWT is it's a multiple format, so you can do many things with it, and sometimes it leads to a security breach, exactly like SSL. You can change the ciphers, the way you're signing stuff, and so read carefully the documentation when you're using it, but it can be a very good solution for your problems. The second possibility is macaron. Macarons are coming from Google, and it's a descriptor format too, and it's working this way. If you ask me for authentication, I give you a macaron back, saying you're allowed to taking the resource in read or write. So when you're making a request there, you're using this crypto token, and you're allowed on the microservice to do read and write, without the microservice has to talk to me. But more, with your macaron, you can craft another macaron saying is hello to doing only read operation. And then what you can do with macaron is delegating the authentication to another one, which is really useful. And if I crush the first macaron, all the descendant macarons will be killed. So this is a very interesting way to interact with microservice because the ability to delegate authentication gives you an extra security vision. The other part of that is in a macaron you can have what we call third-party caveats. So you can, for example, give a macaron saying, okay, I give you this macaron, but it's valid until you are logged into Facebook. So the macaron itself will call Facebook each time you use it to be sure you still log on this. So this ability to do is really interesting, and you can have time constraint too inside the caveat. So basically, if I give you a macaron, you will immediately craft a time-boxed macaron to be able to connect with me and not have, bearer token someone can rob on the network and using it, because it will be time constraints. So it's a very interesting solution for distributing authentication inside large microservice system. So remember, you need to keep hackable and pluggable playground to enforce the innovations inside the team. So when you're building microservice, try to find the right set of tools on configuration, management, and authentication will allow every developer on the team to just say, oh, I have a new idea, I will doing that. And no have to edit the code of every microservice to do it. It have to be simple to just plug something more here and just play because it's fun. But you need to focus on something people often forget, it's the maintenance. When you have a microservice and the microservice is doing good work, you never go to the code to edit it. And there is a problem. You can have legacy and dependency, and you need for a microservice to be there every month, update the dependency, just check in if everything is okay. You need to invest in the maintenance of your microservice, or you will create legacy, very complicated problem with security issue. And the clean legacy code on a regular basis have to be really good. I literally like to remove code. So I use this conference called Y&O Bookkeepers for the IT Management, explaining why it's so difficult to remove codes and management the IT. It's because the way we actually modelize the IT in terms of money. But you need to focus on which code I can suppress. Codes are not a legacy you're giving to your child. Codes are not something you will write for eternity and pile all the code somewhere. Code is something usable at one time to make the business of your organization or company better. And that's it. And this value is only the usage of the value at a precise time. And it's really something you need to focus when you do the maintenance of a microservice. A microservice getting old with no good dependency, nobody wants to use it. Okay, trash it, rewrite it entirely. Because it will be more efficient to do that stuff. For example, when we created the first reverse proxy of Clever Cloud, we didn't get really what was the real mission of the stuff. We spent 9 months to build the stuff, and then in production it was a nightmare. Raise exception, break, out of memory. We basically have everything with this stuff. It was a nightmare, and as it was a reverse proxy, it was not so cool because the reverse proxy is handling the request. And once one of the developers, and we all think it was impossible, because we spent 9 months to write it. And once, one of the developers just go, okay, fuck this stuff, I rewrite everything this tonight. And he spends the night rewriting everything in another language. And we try it in the next day, and 3 days later it was a production. Why? Not because he was so clever. He is very clever. It's not the point, but because he learned in the 9 months before what was the real mission, what was the problem, what was the real due we have with this soft. And rewriting everything was more cleaner than hack inside a code base, which was basically where we learn at the beginning of our mission. So rewriting everything was very, very more efficient. And this soft have been in production for 4 years now, and it's working very well. And it will be switched the next month for a better software. But we don't care. He has been his job. So when you say I'm writing codes, it's not linear, and the code you write in one day is not a constant. Someday you are productive, someday you are not productive, and someday you know what you have to do. And someday you are just discovering your mission. And that's why you can do this kind of stuff. So, the other point is the deployment agility. When you have a lot of microservices, you will need to deploy more often, and deployment become more and more complicated. So if you not automatize all the way code going to production, it will become a nightmare between you and the ops team. And you will spend so much time making deployments that will be not a good idea to using it. So microservice architecture need infrastructure automatization. Do as mentioned that Clever Cloud is doing automating the infrastructure or not? Use or not use Clever Cloud, it's not the point. You can use Kubernetes, you can use a lot of stuff to do that. But if you're going microservice without automate the deployment process, you will have a very bad time, trust me. So, no dogma, just focus on developer happiness architecture. Happy employee write better code. Happy people don't switch and don't go elsewhere. So basically, when you're writing an architecture, think first at developer happiness, and your team will be in a better way. So thank you very much for listening to me.